Hello, this is Professor Klepper, and this is the Earth Science Lab. So we're going to be doing Lab 2, which is looking at the density of minerals. And so I wanted to show you how we actually measure the density of the minerals. We're going to do a small set of the total samples that you have to do for this lab, so just to demonstrate what we are doing. So the density of minerals is referred to as the specific gravity of a mineral, and the definition of that is that it is the ratio of the density of the mineral sample to the density of water. So because of that, we have to measure the weight of the mineral itself, and then we measure the weight of the mineral in water, because we know that water has a density of 1. And so we can use that to actually determine the specific gravity of the mineral sample itself. So let's go ahead, and I've chosen 6 of the samples that are in your sample set. And so we're going to start, so sample number 3. So this is sample number 3. So what we're going to do first is to measure or weigh the minerals dry, and then we will put them in water and get the weight of the mineral in the water, and from there we'll calculate the actual specific gravity. So for sample number 3, we have a weight of 24.59 grams. So I'm going to do this and then I'm going to write it on the board. Sample number 4 has a weight of 63.26 grams, and as you can see, some of these samples are the same size, but they actually have very different weights, so it's just one of the properties of a mineral. Sample 15 has a weight of 48.47 grams. Sample 18 has a weight of 37.93 grams. Okay, so this is sample number 27. So it has a weight of 113.38 grams. And sample number 35, which has a weight of 72.05 grams. So that is the weight of the dry mineral. So let's enter our data up here on our table, and you will enter this into your table that you have. So for number 3, we had 24.59. For number 4, it was 63.26. For number 15, it was 48.47. Sample 18 is 37.93. Sample 27 was 113.38. And sample 35 was 72.05. These are grams. Always remember your units. All right. So in order to determine the weight in water, we will take a beaker this has 200 milliliters of water in it. I'm going to place that on my scale, and I'm going to hit the tare button because I don't want the weight of the water. I know what the weight of the water is. The specific gravity is 1 gram, so I don't need to really know the weight of the water itself. I'm going to be using these tongs to hold the mineral in the water because I don't want the mineral to touch the sides of the beaker itself, because that will alter the weight of the mineral. So because I'm going to be using this, I don't want to measure the weight of my tongs either. So then I'm going to suspend them in water, and I'm going to hit the tare button again. So that way when I put my mineral back in the water with the tongs, it's only going to measure the weight of the mineral. It won't measure the weight of the tongs as well. Okay? So now I'm going to hold my mineral in my tongs, and I'm going to very gently lower it into the water without letting it touch the bottom or the sides of the beaker. And then I'm going to try to hold my hand very still. Is the hardest part. And then as soon as it settles, I'm going to get a weight. All right, so I have 9.12 grams for the, sample number 3. All right, so now because I have dipped this in water and dipped the mineral in the water and then taking it out, I have removed some of the water from my beaker. So now I have to reset everything. So I'm going to hit tare again. I'm going to dip my tongs back in, and I'm going to hit tare. You have to do this after every sample because you are removing droplets of water every time you take this in and out. So you are basically reducing the total amount of water in your beaker. All right, so this is sample number 4. So now when I hold that in there, the hardest thing is holding your hand still. All right, so I have 20 grams even. So if you notice that the weight of the mineral in the water is much lighter than the weight of the mineral itself. Because number 4 was at 63 grams and I measured it at 20 grams suspended in water. So this is sample number 15. Be still. All right, so 15.24. Resetting. This is sample number 18. All right, oops. 12.4. Okay, come on. The joys of science. All right, so this is 27. Wait a minute, yep, that's right. Okay, 15.13. And my last one . Okay. So this is sample 35. Okay, 17.64. All right. So now we're going to enter these numbers. So I had 9.12, 60, oops. You have to enter the right numbers. 20, 15.24 grams, 12.4, 15.13 grams, and 17.64. Okay, so now that I have measured both the dry weight of my mineral and the weight in the water, I'm then going to use the calculation here of specific gravity equals the density, the ds, divided by the dw. So that I will take the weight, the dry weight, divided by the weight in water. I take 24.59 divided by 9.12. So I get 2.69. So So we're going to round that up to 2.7. And there's no unit here. Then we're going to do our 63.26 divided by 20. It's 3.2. 48.47 divided by 15.24 is 3.2. We have 37.93 divided by 12.4. So that's 3.1. 113.38 divided by 15.13, 7.5. And finally 72.05 divided by 17.64 is 4.1. Okay, so this is how we can measure the specific gravity, which is basically the density of the minerals. We take the dry weight, we divide it by the weight of the mineral in water, and we can use this because water has a density of 1 or specific gravity of 1. So we can use this, the weight of the mineral in the water, divide that to get our specific gravity. And so the reason that this is an important process is because specific gravity is one of the properties that we use to identify minerals. So every pure mineral has a measured specific gravity. And so we can tell not only help us to narrow down what the mineral is, but we can also then tell, is it a pure sample or not? Because if I measure something and it has a specific gravity that is not really close to what it should be, then I know there's impurities in my minerals as well. And so this is a good guide and property that we can use when we're looking at minerals. And so in your next lab, you will actually be identifying minerals, and this will be one of the properties that you will use.